Hi, this is Marty with Skincare Science, and welcome back for another video. All right, so as you can see, I have stuff from another video. I'm going to leave it. I don't want to erase it. So this video, I'm kind of amazed that I have to go over this. Not that I mind, but I just want to put this to rest, and hopefully this will, give this discussion, argument, understanding the respect that it's due. And all right, so what I'm discussing is glycolic acid, AHA, BHA, salicylic acid, lactic acid, and the strength and pH, the percentages, and all that good stuff. Again, I'll try to make it simple and straightforward, but I'm going to remove all the guesswork in this video, and well, that's it. So let's get started. All right, so what we have here is we have the two different types of chemical acids very popular in chemical peeling and in the world of aesthetics. Gesner and TCA combination peels won't be discussed at all. All right? Okay, so in order of strength, always consider this. Okay, I don't care who you are, what your education is. Sincerely, I don't. This is the strength, this is the order. Alpha hydroxy acids, AHAs, and BHAs, beta hydroxy acids, are in order of strength in that order. Alpha hydroxy acids, AHAs, are stronger than beta hydroxy acids, BHAs. I don't care if you think that salicylic acid is as strong. What you're doing by saying that, what you're doing by educating that, is confusing. So if you are an educator, or if you do teach other people, stop doing that. Here's why. You have to think about the industry, and you have to think about what the industry is pushing. The industry pushes superficial peels through the use of alpha hydroxy acids and beta hydroxy acids in the order of glycolic acid is used for pigmentation and softening of fine lines and wrinkles within the face. It's superficial. Beta hydroxy acids do the same and are primarily used for acne. But what ends up happening is within the industry, I think it's just to sell product. I don't even understand it, but they just start to convolute the strength of salicylic acid. Stop it. That's the best way I can explain it, okay? Because if you keep it simple and you say this, if you're going to use, across the Fitzpatrick scale, if you're going to use an acid and they don't have acne, and you're on a 2 on the small scale of the Fitzpatrick scale, go to glycolic acid. If that same patient has acne, go with salicylic acid. But as it relates to strength and what you should or should not be using, let's go in this order as it relates to a non-acne or non-acneic skin type. Glycolic, lactic, salicylic acid, all the time. Okay? The reason for that is because not only does that stick with industry standard and keeps everyone on the same understanding, meaning estheticians, professionals, and end users, but it also clarifies for the professional and for the end users, when do I use salicylic acid? Oily skin. So if you're going to use an acid across the Fitzpatrick scale on the small scale, 1, 2, or 3, okay? Well, you can alternate between glycolic and lactic. The second you see an acneic skin type, immediately go with salicylic acid. One and done. That's it. It's not confusing. Okay. So what I'm going to do is I'm going to draw a little chart here, and I'm going to show you. So I'm going to put the large scale on the bottom, small scale on top, and then I'm going to show you. So here's 1, 2, 3, 4, 5, 6, okay? 1, 2, 3. Okay, you ready? When do I use glycolic acid? Right there. When do I start with no acid experience whatsoever? When do I use lactic acid? Right there. Simple. When do I use salicylic acid? On any of those skin types. When they have acneic skin, when there's oil or pimples present. Is that all the time? No, it's not. But if you don't have any experience and you're looking for a foundation to start on, this is it. Okay? I don't care how much experience you have. I don't care if you're a medical doctor. I'm telling you, I'm right. 100%. There's no question, I'm right. Okay? You can mix it up and you can play with it and you can grandstand, you can make yourself blah, 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 whatever. This is right. It is 100% right. Okay? All right. that should go over really well. Okay. All right. Now what we come down to is, and I need to be very careful here, otherwise I'll be talking about like that and then it all looks bad. All right. So what do we have here? We have percentage and pH, okay? And I'll bring in time later, all right, at the end of the discussion. All right. Okay. How do we know if we're not considering the Fitzpatrick scale and we're not considering anything, I mean any of this stuff, we are just looking at whether or not it's an acid or not. Okay, and what I mean by that is, just because it says glycolic acid, lactic acid, or salicylic acid, and has the word acid in it, does not mean when it is in a solution that it is going to act like an acid. Okay? So if you ever see a bottle of anything that says this has glycolic, lactic, or salicylic acid in it, and the pH starts or is above 3.8, give or take, remember there's a range, forget about the acid. That pH is going to treat and force that acid into an alkaline environment, and I'm simplifying this, and it will no longer act as an acid. It is now just a normal hydrating liquid. That's it, okay? So, when you look at glycolic, lactic, and salicylic acid, this is always first. Well, on my T, okay? Always first. I always want to know what pH I'm looking at, okay? When it comes to the percentage, which is second, and the reason I paused is because this gets kind of complicated at this point. All right. If you do not have a high enough percentage of acid within the solution, say under, really it's 20 to 30%, and the rest being non-acids, or to simplify this, water, the water pH and the acid, when they combined, are going to divide by 2, kind of, sort of, and then you're going to have a different pH. A solution of acid at 30%, give or take, is going to have a hard time being above 3.0. I'm sorry, below 3.0. All right? You need to have enough acid to offset the other liquids so that that liquid doesn't bring in, or so I'm sorry, doesn't bring down the percentage. How do they do that when you see 10% glycolic acid at a pH of 2.0? It's easy. They're adding in another acid. Okay? This is simple. Skincare science in the Serene, I don't do that. When you peel with serene, I want you to know what you're dealing with. So pH is first, percentage is second. All right? Always. Okay. All right. Now, this is where it gets kind of tricky. All right. So if you have glycolic acid, I'm going to make some examples here. If you have glycolic acid at, say, 50%, okay, and you have pH at 3.0, that is going to be a weak glycolic acid peel. And the reason why is because 50% solution gives you the ability to have a 2.0 pH. So that means there's something other than that's buffering it up, meaning reducing, look at the scale, up the scale, okay, reducing the strength of the acid, all right? So if you have 40% lactic acid at 2.0 pH, even though lactic acid is the weaker of the two AHAs, this tells you that it is stronger regardless of the extra 10% here and the fact that lactic acid by chemistry standards is a weaker acid. You see how that works? Now here's the thing. Time, and let me just write this here, I can probably get this here. Time is your third variable. If I keep, because these are all time dependent, TCA and Jesner are coat dependent. Okay, so if I leave lactic on with this for 5 minutes and I leave glycolic this at 10 minutes, 7, which is theoretically possible, now your glycolic acid is now the stronger chemical superficial peel. But if I erase this and invert them to there and there, well, obviously, now look, we have the weaker lactic acid of the AHAs, we have a 10% reduction in the percentage of volume of acid within the liquid, we have a full measure 1.0 pH difference lower down the acidic scale instead of the alkaline way. This is more on the alkaline direction, okay? 10-minute time frame, extremely strong peel. Remember, they're all superficial. You are never going to see actual protein coagulation with any of these peels. They are not protein coagulators. Okay? I'm going to draw a little picture. Well, where can I draw a picture? I'll draw a picture right here. Skin cell, here, and here, and here. All of these acids work in this space. TCA and Jesner work through that space. They destroy everything in its path. Okay? When you look at salicylic acid, remember, salicylic acid is, well, salicylic acid is not a protein coagulator. If you see anything that resembles a white haze, anything, that is precipitation. What that is the evaporation and the left behind salicylic crystals, basically. It is self-neutralizing, but I have never read, and if you've seen other videos I've done, I've never read where how salicylic acid within the skin is self-neutralizing. What in the skin is neutralizing that beta hydroxy acid? I've never read it. If you have it, email it to me, send it to me. So as it relates to strengths, if you see a 20% salicylic acid, 3.0 pH, time frame, I don't know, 3 to 7 minutes, that, in my opinion, is going to be equal to the lactic acid. But remember, the molecular structure of salicylic acid is going to allow it to penetrate into the hair follicles and be much better and more efficient at treating acne. Okay? My favorite acne treatment is trichloroacetic acid, not any of these across all Fitzpatrick scales. That's just me. Okay. Now, if you questioned why I said salicylic acid is equal to lactic acid, okay. The reason why is because, for simplicity, I said look at it in this order, because the only time you're going to be looking at salicylic acid is when there's acne. All right? Does that mean that you can't use glycolic and lactic for acne? No, it doesn't. You can use them all, but because of the molecular size of salicylic acid, that's what it's used for, and that's what it's popular for. And remember, I'm educating professionals. And by the way, if you're retail and you're watching these videos and you're buying outside of me, don't watch my videos. Seriously, go somewhere else. You'll piss me off, because you're not supposed to be getting this education and then buying these. So freaking get off my channel. I'm serious. Okay, all right. So as it relates to salicylic acid and lactic acid, the reason why I did that arrow is because if someone asked me for the truth, do you believe lactic acid is stronger than salicylic acid? The answer directly would be no. But to make this simple, based on the industry, based on popularity, I'm sticking with this: glycolic, lactic, salicylic acid. I'm sticking with this. Okay? Glycolic on 2, on 3, 4 on the large scale. Glycolic down the scale toward African American skin, darker skin types, 5, 6, or 3 on the small scale. Lactic. Going this way, 1, 2, 1 on the small scale, lactic acid. Salicylic acid on all of them. Modulate your time. Okay? As you know, salicylic acid poisoning, you do someone's whole back, you're going to have a problem. So keep it to 6 square inches at a time, and that's it. Okay, what's it called? Salicylic acid, salicylic poisoning or something like that? Yeah, I mean, I don't discuss it too much and I don't talk about it too much, because Forrest Gump, stupid is as stupid does. If you're going to do a whole back with salicylic acid, then you have no clue what you're doing and go back to school. Okay, so I hope that this simplifies everything as it relates to the strength of these acids, where you should be looking first, how percentage, pH, and time give you a direct indication of the potential strength and the care that you need to take as it relates to results and potential post-peel complications. That's all I got. Okay, so I hope I answered all the questions. Let me look at it for a second. Yeah, yes, I think that just about does it. I'll do another video if I missed anything. Put the comments below. And this is Marty with Skincare Science, and we'll see you in the next video.